All right, this video is going to discuss a different transformation. So the last one was your amplitude, which talked about if it was vertically stretched or compressed. But this one is going to talk about what happens when you add something onto the end. So taking from what I learned on the last video, if I look at this equation, I know my amplitude is 1. And if I look at this equation, I know, just hopefully from the last video, because of that 3 in front, my amplitude is 3. And on this equation, I know my amplitude is 1/3. Now, just to save time with these videos, is you could go ahead and graph and see. You could graph all of these on Desmos, and I encourage you to, especially if it's not truly clicking quite yet. But once I graph all of them on Desmos, my periods will also still remain to be 2 pi. We'll see when they aren't or they change. So going to Desmos just to look, we'll go ahead and graph some of them. I thought I could get away with it, but I can't. I'm going to go ahead and plot the cosine function so I have something to compare it to. So that's my parent function. I'm going to graph, and I already forgot what they are, so I have to look again. I'm going to graph this one and this one. Okay, hopefully I can remember. Okay, so my y equals 3 cosine x, and I don't remember already, but just looking here, let me go ahead and get this smaller. We can see that my amplitude here is 3 for this new graph. And I believe, oh man. Okay, it's a -1 and a +4, so I don't forget. So I'm going to -1 now from this graph. All right. Now, looking at that, it looks like, oh, wait, from that one, it looked like it shifted it down, right? So if I get rid of it, let's pay attention to that. There it is, right? And if I -1, it looked like it went down a unit. Now this one, and then it was so there's that purple graph, okay? And it got vertically compressed by 1/3, so we see 1/3 is my height. Now I'm gonna add 4. I don't see it, so that might happen to you. So I'm gonna zoom out, and there it is. So it looks like I picked up that graph and I moved it up 4 units. So going back here, when you have an addition on the end, like when that would be this one right here, it went up d units. And this one, it went down d units. So another way to write that is we could say vertically shifted down d units, or vertically shifted, oh, forgive me, up was this one, right? Because it was a plus. And this is down d units. So what I want you to take away from this is, oh man, I can just look at these graphs and know what's going to happen. Well, there's another thing we could call this vertical shift. And if you look here, let's just focus on the green graph. So I'm going to take this away and take that one away. Well, where we see -1, that is right here, right? Well, you can't see me selecting it, but hopefully put your pencil at -1 or your eyes at -1. Do you see how that would cut the graph in half, right? Well, we talked about in the previous video that means this could be known as our midline, which is really cool. So I'm having us graph just cosine x, just getting us really good at plotting that. And then I'm going to have us graph cosine of x with some transformations on it. F of x cosine of x is, the amplitude is 1. And our period, again, I would look at a visual, but hopefully you're convinced it's 2 pi for cosine of x. And now we have learned that the amplitude for g of x, we learned it has to be 3 for that function. And again, our period is 2 pi. So if I'm plotting cosine of x, I gave you those tools in the previous video. I felt like the one I last graphed was a little squished, so I'm going to go every other tick mark just so it's easier to read. So that means I'm going to go out to 2 pi. I'm going to do the same. You have to be consistent. So on this direction, negative 2 pi. And then I'll go up 1 and down negative 1. Again, cosine we talked about, or you could go back to your chart, your unit circle, whatever you need in the beginning to make it stick. But if I put in 0, I get out 1. Then I hit the x-axis again, and then I hit a low point, x-axis, high point. Again, that's all coming from the unit circle. If I change direction, the pattern continues. And so this, I'm having us graph A to get better at graphing, but then also what are we comparing it to? So when I look at g of x, I know, oh wait, from the previous video, I have vertically stretched this by a factor of 3, so this graph needs to get taller. And then we just learned just by looking at some graphs, that means it's been shifted down a unit. So let's give ourselves a scale. I always go off this to help me with the scale, so I know my end tick mark will be my period. And this one, I'm going to go up 1, 2, 3. Just make sure you give yourself enough space. Sometimes I commit to a scale and I run out of space. And I actually know I am going to get out of space because I have to shift this down a unit. So what I'm going to end up doing actually, it's a good lesson to show. I'm going to choose a different scale because I don't want to run out of space. So I'm going to actually 1, 2, 3. 1, 2, 3. Well, we just looked that this, my midline for this one would be y equals negative 1 because that's where it cut it in half. And let me just remind you, for this function, my midline is y equals 0. So the nice thing is I would plot your midline first because I know this, let me get that a little bit better, it went a little crazy. This is going to be where my graph is cut. Well, now what you look at is that midline is now your x-axis, okay? Because you've already shifted it down a unit. The old way is you could plot all of these points and just shift everything down and stretch it and so forth. But this is an easier method. All right. My first point is a high point with cosine. So that means from my midline, I have to go up 3 units. So I go up 1, 2, 3. So I end up right here. Then my next point, I hit my x-axis, but this time I'm going to hit it here because it got shifted down a unit. My next one is a low point, so from my midline I have to go down 1, 2, 3. I hit my axes again, and then at 2 pi, it's a high point. So from there I'm going to go up 1, 2, 3. So here is 1 period. But we always want to graph 2 full periods, so I'm going to go on this side. And just follow the pattern. Okay, I hit the x-axis, so this one I'm going to hit here. And then my next guy is a low point. So 1, 2, 3. Hit the x-axis, my midline, and then hit up here. So here, is 2 full periods. Now what I want us to do, and I have not done it yet, but I really should be, label 3 points always. So I'm going to tell my reader this point is 0, 2. And we should maybe make that guy go through that point a little bit better. This point, and you can choose any point you want. This point here is going to be, looks like pi -4. And I want 3 always, so then I'll go choose, I don't know, 2 pi 2. And what I'm going to do is I'm going to go to Desmos and make sure that's right by comparing my coordinates. And you won't have Desmos when it comes to test time, but it's good to, get practice in so it makes sense. So I can't see it, so, oh, I have to do that. That's why I can't see it. So if I select the points, all right, 0, 2, that checked out with something I listed. Pi -4, that checks out. 2 pi 2, yeah, looks good. Another way to check your work is you could do yourself, let's see, g of 0, go to our algebra days, 3 times cosine of 0 minus 1. Well, what is cosine of 0? That's 1. What's 3 times 1? 3. 3 minus 1 is 2. Checks out. All right. Next video will be on, something else.